Hello and welcome to Astronomy Daily, your cosmic companion for all things space and astronomy. I'm Anna, and today we've got a stellar lineup of fascinating stories from across the universe. Coming up in the next 20 minutes, we'll explore Amazon's space ambitions as their Project Kuiper satellite launch faces delays on the launch pad. Then we'll check in with NASA's Juno spacecraft, which recently experienced a scare while orbiting the harsh radiation environment of Jupiter. We'll also dive into intriguing new research about the potential for life in the subsurface ocean of Saturn's moon Titan and examine how lunar samples from China's Chang'e 6 mission are helping scientists understand the violent birth of our moon. And to cap it all off, there's an exciting celestial visitor you might want to wake up early to see. The newly discovered comet Swan is brightening in our morning skies, and amateur astronomers are already capturing stunning views. So let's launch right into today's Cosmic News Roundup. It seems Amazon may be a wizard at delivering packages to your doorstep, but delivering satellites to orbit proves a bit more challenging. A United Launch Alliance Atlas V rocket was set to carry 27 satellites for Amazon's Project Kuiper internet constellation into orbit from Cape Canaveral Space Force Station this week, but Mother Nature had other plans. Persistent clouds near the launch pad violated safety rules, forcing ULA to scrub the launch despite working through a full 2-hour launch window. Launch controllers battled not only technical glitches, but also thick cumulus clouds and rain within 10 miles of the pad, ultimately making the call to delay the mission. Project Kuiper represents Amazon's ambitious leap into the space-based internet market, directly challenging SpaceX's Starlink constellation that's already providing high-speed internet to customers worldwide. Amazon isn't thinking small either. They're planning to deploy a massive constellation of 3,200 broadband satellites in the coming years. This launch would have been Amazon's first operational deployment of Kuiper satellites, following a successful test flight last October that carried 2 prototype satellites to orbit. While ULA is handling this initial launch, Amazon has wisely spread its bets across multiple launch providers. The e-commerce giant has secured flights on several different rocket systems, including ULA's brand new Vulcan Centaur rocket, Ariane space boosters, Blue Origin's New Glenn, and interestingly enough, even their direct competitor SpaceX's Falcon rocket family. This multi-provider approach helps ensure Amazon can maintain its deployment schedule, even if one launch system faces delays. The satellite internet market is heating up rapidly as companies race to provide global connectivity from space. While SpaceX currently dominates with thousands of Starlink satellites already in orbit, Amazon brings considerable resources and a massive potential customer base to the competition. These constellations promise to bring high-speed internet to remote and underserved regions around the world, where traditional infrastructure is impractical. ULA and Amazon are now working with the U.S. Space Force to identify the next launch opportunity, hoping clearer skies will allow these first operational Kuiper satellites to finally reach their orbital destination. Next up, a bit of a scare while a long way from home. NASA's Juno spacecraft has experienced an unexpected hiccup during its ongoing mission to Jupiter. The space agency reported that the solar-powered spacecraft entered safe mode not once but twice on April 4th while conducting its 71st close flyby of the gas giant. Safe mode is essentially a spacecraft's self-preservation state. When Juno detects an anomaly or something unusual, it automatically switches to this precautionary status where it shuts down non-essential functions and focuses solely on critical tasks like maintaining communication with Earth and managing power. As designed, Juno's science instruments were powered down for the remainder of the flyby when it entered safe mode. The good news is that mission controllers have successfully re-established high-rate data transmission with the spacecraft, which is now running flight software diagnostics. The team is working to download all the engineering and science data collected before and during the safe mode events. What's particularly interesting is that during both incidents, Juno performed exactly as it was designed to, rebooting its computer, shutting down non-essential systems, and pointing its antenna toward Earth to maintain communications. Jupiter presents arguably the most hostile environment in our solar system, with radiation belts near the planet that would quickly fry unprotected electronics. Early indications suggest that Juno's safe mode events occurred as it flew through these intense radiation zones. To shield against this extreme radiation, Juno is equipped with a titanium vault that houses and protects its sensitive electronics. This isn't the first time Juno has experienced such issues. Since arriving at Jupiter in July 2016, the spacecraft has unexpectedly entered safe mode 4 times, including these recent events. The previous incidents occurred in 2016 during its second orbit and again in 2022 during its 39th orbit. In all cases, the spacecraft recovered fully, demonstrating the effectiveness of its protective systems. Despite this minor setback, Juno's mission continues. The spacecraft is scheduled for its next close approach to Jupiter on May 7th, which will include a flyby of Jupiter's volcanic moon Io at a distance of approximately 55,300 miles. This upcoming encounter with Io, the most volcanically active body in our solar system, promises to deliver fascinating new data about this enigmatic Jovian moon. The Juno mission, managed by NASA's Jet Propulsion Laboratory, continues to provide invaluable insights into Jupiter's atmosphere, magnetic field, and interior structure since its arrival at the gas giant nearly 8 years ago. Next on our story list today, could Saturn's largest moon Titan harbor life in its hidden ocean? New research from the International Space Science Institute in Bern, Switzerland suggests it's possible, but with significant limitations. A multidisciplinary team has been investigating the potential habitability of Titan's subsurface water ocean, focusing specifically on whether a metabolism called glycine fermentation could support microbial life there. Unlike some metabolic processes that require strong oxidants, glycine fermentation could potentially work in Titan's ocean environment. The researchers used bioenergetic modeling, the same approach previously applied to Saturn's moon Enceladus and early Earth ecosystems, to assess the energy available for potential microorganisms. Their findings suggest that Titan's ocean could theoretically support heterotrophic life forms, organisms that consume organic material rather than producing their own food through photosynthesis. What makes Titan particularly interesting is its abundant surface organics. The moon has lakes and seas of liquid methane and ethane, with a thick atmosphere rich in nitrogen and methane. However, the study found that only a limited fraction of these abundant surface organics would be suitable for microbial metabolism. Furthermore, there's a transportation problem. The organic material from Titan's surface has difficulty reaching the subsurface ocean where potential microbes might live. The primary delivery mechanism appears to be through impact-generated melt pools, essentially when meteorites crash into Titan and create temporary melting that allows surface materials to mix with the subsurface ocean. This inefficient transport means any potential biosphere in Titan's ocean would be extremely sparse. The study estimates a total biomass ranging from just a few grams to a few kilograms of carbon across the entire moon. To put that in perspective, this would equate to fewer than 1 microbial cell per kilogram of water when diluted throughout Titan's enormous subsurface ocean. These findings highlight both the possibility and the challenges of life existing in Titan's hidden ocean. While the basic ingredients and energy sources for life might be present, the difficulty in delivering nutrients to potential organisms creates a significant hurdle. The research team notes that further studies into alternative metabolic pathways and potential nutrient delivery mechanisms are needed to fully understand Titan's habitability potential. Despite these limitations, Titan remains one of the most intriguing places in our solar system to search for potential extraterrestrial life, a world with a complex atmosphere, surface lakes, and a hidden ocean that continues to fascinate astrobiologists. Meanwhile, a bit closer to home, and the discoveries keep coming. Fascinating news from China's Chang'e 6 mission, which recently returned the first-ever samples collected from the far side of the moon. Analysis of these precious lunar materials is revealing important differences between the moon's familiar near side and its hidden far side, differences that may help confirm how our moon formed. Scientists examining the Chang'e 6 samples have discovered that there's significantly less water in the mantle beneath the far side of the moon compared to the near side. The samples from the South Pole Aitken Basin on the far side contain only about 1 to 1.5 micrograms of water per gram of sample. That's substantially lower than measurements from Apollo mission samples from the near side, which show up to 200 micrograms of water per gram. This water content difference provides important evidence supporting the giant impact hypothesis, the leading theory that our moon formed when a Mars-sized protoplanet collided with the early Earth about 4.5 billion years ago. The impact sent a cascade of debris into orbit that eventually coalesced to form the moon we see today, According to Professor Hu Sen from the Chinese Academy of Sciences, we believe the new result is in line with the giant impact hypothesis of the moon. Computer modeling of such an impact event predicts that the moon's mantle would have a dichotomic or two-part distribution of water, exactly what we're now observing. The water content difference is just one of many distinctions between the two lunar hemispheres. The near side features vast, dark plains of ancient volcanic flows that we can see with the naked eye. Meanwhile, the far side has a much thicker crust with far fewer volcanic features, different rock types, and varying concentrations of elements like thorium. Thorium provides a useful proxy for water content because both remain in magma during melting rather than forming crystalline minerals. The South Pole Aitken Basin is one of the few areas on the far side with significant thorium, as it's a massive impact basin where the collision dug deep enough to bring material from the mantle to the surface. At 1,600 miles across, the South Pole Aitken Basin is one of the largest impact structures in our entire solar system. The effects of this colossal collision would have profoundly influenced the moon's evolution, particularly on the far side. These new findings remind us that despite being our closest cosmic neighbor, the moon still holds many secrets, especially on its perpetually hidden far side. As one scientist quipped, despite being as dry as a bone, the moon's far side continues to be one of endless fascination. Finally today, one for all skywatchers. In exciting astronomical news, a recently discovered comet is brightening in our skies and might soon be visible to the naked eye. Comet Swan, officially designated C2025 F2, wasn't found through a traditional telescope, but instead through careful analysis of images from the Solar Wind Anisotropies camera aboard the orbiting Solar and Heliospheric Observatory. The discovery honors a great tradition of civilian contributions to astronomy. On March 29th, 3 amateur astronomers independently spotted the moving object in publicly available SWAN images: Vladimir Bezugli from Ukraine, Michael Matiazzo from Australia, and Rob Matson from California. Following naming guidelines, the comet takes its name from the instrument that captured the images, rather than the individuals who made the discovery. Word of the new comet spread quickly through the amateur astronomy community, with observations pouring in shortly after. Currently glowing at around magnitude 8 to 9, it's already visible in small telescopes despite its low altitude in the eastern pre-dawn sky. Observers have reported a well-condensed coma approximately 3 arc minutes across, with a slight blue-green coloration from fluorescing carbon compounds. The comet appears to be brightening rapidly. The Central Bureau for Astronomical Telegrams now forecasts it could reach magnitude 3.6 around perihelion on May 1st, when it passes just 31 million miles from the Sun. That would make it potentially visible to the naked eye under dark skies, though the brightness prediction comes with a caveat due to the comet's recent outburst behavior. For the next couple of weeks, Comet Swan remains a morning object visible in the northeastern sky during dawn, currently moving about 1.75 degrees per day through the Great Square of Pegasus before traversing Andromeda and Triangulum. Around April 25th, it transitions to the evening sky, appearing low in the northwest after sunset. Northern Hemisphere observers are particularly well positioned to view this visitor, with the best viewing window happening now through early May. On May 1st, it will pass just 2 degrees north of the beautiful Pleiades star cluster, creating a potentially spectacular photo opportunity. Southern Hemisphere skywatchers will get their turn starting around May 4th, with extended viewing opportunities throughout the remainder of May. If you're planning to observe the comet, you'll need a location with an unobstructed northeastern horizon. While binoculars or a small telescope will give the best views now, if brightness predictions hold, it might become a naked eye object as it approaches perihelion. And that wraps up our cosmic journey for today. From Amazon's efforts to spread internet access from above, to the resilience of NASA's radiation-hardened Juno spacecraft, from the tantalizing possibility of life in Titan's hidden ocean, to the lunar samples illuminating our moon's violent birth, and finally to our unexpected visitor, Comet Swan, brightening in our skies. The universe continues to captivate us with its endless wonders. I want to thank you for spending this time exploring the cosmos with Astronomy Daily. Whether you're a seasoned stargazer or just beginning to look up in wonder, there's always something new to discover about our magnificent universe. This is Anna, your guide through the stars, signing off for today. If you're hungry for more space news, visit our website at astronomydaily.io, where you can catch up on all the latest space and astronomy news with our constantly updating newsfeed and listen to all our back episodes. You can also find us across social media. Just search for Astro Daily Pod on Facebook, X, YouTube, YouTube Music, Instagram, and TikTok. Until next time, keep looking up.